Hello out there in YouTube, MeTube, everywhere, YouTube land. I'm Duck, which is double F-bomb spelled sideways, sort of. And the subject today is falling floors and rising fallers. I'm here to revisit a myth which has been a long time busted myth regarding what usually is referring to like what to do if you're in a crashing plane or falling elevator. Namely this jump up at the last second before you hit to save your life thing. I don't know how long people have sworn by this and without being contested, and the myth eventually was busted. But one of my issues about the busting of the myth is that the myth was not quite in fractional terms reduced to its lowest terms or simplest form. Now in fractions is fractional math, you know, that's where I got the idea of lowest terms or simplest forms, is like reducing 8/16 to reducing 8/16 to 4/8 or 4/8 to 2/4 or 2/4 to 1/2. I think you kind of get the picture. One of the things is that I'm sure one could easily debate whether or not a falling elevator is capable of accelerating to a true skydiver's free fall terminal velocity of 120 miles an hour. That's probably something that could be debated long enough to fall from Pluto or something like that. But what I'm getting at is, okay, let's just assume that a falling elevator that you're in, or a falling balloon gondola, you know, something that's descending that has a floor that you can jump off of. Let's say it's descending at a rate of about 50 miles an hour. Let's just say you can jump up at a speed of 50 miles per hour. Let's say you do that just before you impact. And yeah, that, you know, I would call that total impact cancellation. And yeah, it would cancel the impact, but bear in mind, impact cancellation is also impact replication. Because basically you'd be subjecting your body to the same G-forces as you would be just passively absorbing the impact, because you're experiencing the same deceleration, and in some ways it's more stressful on your body. And the fact is, if jumping up, if you can jump up at that speed and not get hurt, you can not jump when you impact and not get hurt even more. That means get hurt less. And so anyway, let's try something that would involve doubling the stopping distance, which would basically involve cutting the jumping up speed in half. You know, let's say you're descending at 50 miles per hour, so we jump up at 25 miles per hour, which is half that speed. And that will basically double your stopping distance if you time it just right. And basically what you'd be experiencing is two 25 mile per hour impacts, which is not the same as one 50 mile per hour impact. It's basically the same speed being reduced over a greater distance. It's more gradual, therefore you experience less G-forces, because the impact of if you double the impact speed, you quadruple the impact force, because the impact energy is proportional to the square of the impact speed. So therefore, two 25 mile per hour impacts is less severe than one 50 mile per hour impact. However, unless you're a kangaroo or a cougar who can jump up to 20 feet, I don't know how much that height it achieves by inertia alone. For the maneuver to work for you, I mean, we'd have to be, for us humans, it would have to be going with a velocity of more like about 16 feet per second, which is the equivalent of a jump down from 4 feet, I believe. Let's say you can jump up at a speed of 8 feet per second, which should be about the equivalent of jumping up 2 feet, which I think most people can do. And that would cancel out half that speed. 16 feet per second, that's roughly about what you would descend under a parachute or under a, or at least under a large sport parachute. So 16 feet per second is, actually at 16 feet per second under a parachute, you could go unhurt without jumping up, just passively absorbing the impact. The question is whether or not jumping has any advantage over doing the regular PLF, which I don't believe that it does, because it has to be properly timed, and if it's not properly timed, it can make things even worse. Whereas when it comes to a PLF, a parachute landing fall, all you have to do is wait for it to happen. You don't have to worry about timing. That's completely out of the equation. I mean, jumping up may, if you do it just right, may do some things to soften your landing, but like I say, it would have to be precisely timed. But like I say, and if it's not precisely timed, it could actually make it worse. Just for the sake of argument, the best timing for a jump, if you want to do that maneuver, is such that your feet leave the floor of the elevator at precisely the instant that the floor of the elevator hits the ground, because that is when you're going up at your maximum speed relative to the floor of the elevator, therefore your lowest speed relative to the ground that you've just hit. And basically that helps to double your stopping distance and makes your landing a little bit significantly softer. If the floor of the elevator hits the ground when you're at the peak of your jump, it kind of gives you a running start at the floor, and will make you hit harder. What would make you hit even harder would be if the elevator floor hit the ground at the same time. Okay, the reason that what happens when you're at the peak of your jump is you've just re-equalized your speed to that of the falling elevator floor, and then when it hits, you're coming at it all the faster. It's not as bad. The reason it's not as bad as it would be if the floor hit the ground at the same time that you hit the floor is because it doesn't have as much time to accelerate during that time. Whereas if the elevator, if the floor hits the ground at the same time your feet hit the floor, it's had more time to, it's been accelerating longer, so that's what would make the impact the most severe. And hopefully you can find the right body position to make up for it, which you probably should have held in the first place. So as Superman would say, BRB.